To start off this lesson, we'll do a brief review of some of the important things we've gone over so far. To bisect means to cut into two congruent pieces. This can apply to both segments and angles. The four theorems we've used so far to prove that two triangles are congruent are side, 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 angle, side, angle, angle, side, and angle, side, angle. Vertical angles are always congruent, so when you see this crisscross pattern, you know that these two are going to be congruent. And perpendicular lines form right angles, which are also congruent angles. So today we're going to add one more theorem to how to prove triangles congruent. However, this specifically applies to only right triangles. The reason why is because it is called the hypotenuse leg theorem, and there is only a hypotenuse in a right triangle. So if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another triangle, then the triangles are congruent. So in order to use hypotenuse leg, you need to have a right triangle. So you need to have a right angle in your triangle, right? So this is a breakdown of what a right triangle will look like. The hypotenuse is always across from that right angle, and there are two legs. So again, to use this theorem, you must know that there is a right angle, therefore it is a right triangle. If it is not a right triangle, you should not be using HL. This is why it's introduced last, because this is a very specific theorem that cannot be used for any types of triangles. So if I want to use the HL theorem, what additional information do you need to prove that the two triangles are congruent? If we look at one, we are given that it is a right angle. That's weird. I don't know why that did that. Hold on. Getting a sneak peek at everything. Okay. If you look, we are given that they are a right angle, so it is a right triangle. That's good. I'm given that these two sides are congruent. They are not opposite of my right angle, so I need to know that the hypotenuse is congruent in both of these triangles before I can use HL. If I look at 2, I have a right angle. That's good. I have the hypotenuse because it is across from the right angle, so I would need to add a congruent leg in order to use HL. In number 3, the only thing that is marked is the type of angle, so I know it is a right triangle. However, I don't know anything about the sides, so I would need to know that both the hypotenuse and the leg of the corresponding triangles are congruent. So if you remember on that sheet with the important theorems and postulates, this is the sequence of lines that you would write if you were given right triangles and you wanted to state that use the HL theorem given that you knew a hypotenuse and a leg were congruent. So here we have an example of how we can use HL. So let's zoom in before we start looking at all the words. We're given that AB is perpendicular to AC, so there is a right angle. So we have one right triangle here. Or also know that BD is perpendicular, to CD. So I have another right angle. So I have two right triangles, so we're in good shape to use HL so far. We know that AB is congruent to DC, so this is the opposite sides. And now if we look, the hypotenuse of both of these triangles is going to be BC. So I can say that the hypotenuse of both are congruent because they are the same side. So I'm going to use reflexive to get the hypotenuse, which is the only thing I need to add here after I state the right angles and that I have right triangles. So first, of course, we write our given statements. I then clarify that there are right angles based off of the definition of perpendicular lines. Because of this, I know that there are right triangles. So this allows me to use the hypotenuse leg theorem. You kind of have to go over that hurdle before you can use hypotenuse leg. It's like showing your card saying, hey, look, I've got right triangles. I'm good to use this theorem now. Now the last piece is that BC is congruent to BC because this gives us our hypotenuse. Our leg was given to us, so our triangles are congruent. So for which situation could you immediately prove that triangle 1 is congruent to triangle 2 using HL? So I need the hypotenuse and the leg, right? So if we look at number 1, all that's labeled is the right angle and these angles. Now you could say that there is a congruent leg here, but I'm not given anything about these sides. So this one, no, I don't like this. There's not enough information. No bueno. Now, number 2, I can prove that they are congruent. However, if we look, the hypotenuse is not labeled, right? So we know that they're right triangles because if this is a right triangle, then the whole square, if this is right angle, the whole square is right angles. But what they give us is 2 legs. I can prove that these are congruent by side, angle, side, but that's not what the question is asking. The question is specifically asking about the hypotenuse leg theorem. So I know that I cannot use HL on 2 because I do not know anything about the hypotenuse. Number 3, since there is none option for this question, you could just say by process of elimination that, 3 must be. But let's take a look at it. I have my right angle, so I know that they're right triangles. Reflexive would give me a leg, and they give me that the hypotenuse are congruent. So by HL, these triangles would have to be congruent. Is there enough information to conclude that the 2 triangles are congruent? If so, what is a correct congruent statement? So let's look at this. Right angle, right triangles. Good. I know that there is a shared side, so AC is congruent to itself, which is our leg, and our hypotenuses are given to us, right? So here I know that AB is congruent to AD. The reason why I am pointing this out is because it is important when you look at the answer choices. Because if you look, the order matters when we're talking about corresponding points, right? So AB has to be in the same order as AD. So if you look here, AB is not the same as AC. So A would be right out. And we know that they can be proven congruent, so D is out as well. So now I'm between B and C. So you're looking for AB is congruent to AD. Now here it's a little tricky because they're first and third, so they're not right next to each other, but you have AB, AD. Therefore, these two, ACB is congruent to ACD. Corresponding parts have to be in the same order for a correct congruence statement.